Hello and welcome to Algebra 2. Today is the start of Chapter 10. We're going to talk about 10.1. So Chapter 10 is quadratic relations and conic sections. 10.1, we're going to discuss distance and midpoint formulas, and this should be a review from geometry. So before we get started, just kind of an intro here. How would you find the distance between 2 points? And so obviously, if your points were either horizontal or vertical to each other, you can count the distance, and that's not an issue. So what happens, though, if the points are at some sort of angle with the horizontal? How do I find that distance? And so one thing I've suggested here is what happens if you make a triangle. So if you complete this triangle, is there any way that you could find that distance? And so for the sake of it, we're going to call this side over here C. Is there some way we could find C? Well, you should happen to know the Pythagorean theorem, right? And so if you specifically just want C, if I square root both sides, you get C equals the square root of A squared plus B squared, with A being one of the sides and B being the other. Okay, and so we'll elaborate on that a little more later. But what about if I wanted the midpoint? So if I specifically wanted the midpoint of this side, how would you find that midpoint? Well, hopefully it makes sense that the midpoint is the average of the two endpoints, because it's halfway between. So if I add the x's together and take halfway, and if I add the y's together and take halfway, that's that point that I get there. Alright, so let's actually get started here. This is the distance formula, and it's d equals the square root of the quantity x2 minus x1 all squared plus the quantity y2 minus y1 all squared. Very similar to what I was just showing you with the Pythagorean theorem. It's just that this is A and this is B because we have to get the values of those sides. So if you specifically know these two ordered pairs that are endpoints, the way you get the length of this side is by subtracting their x values, and the way you get the length of this side is by subtracting their y values. So it is the Pythagorean theorem, except we've just put in some ordered pairs because we have to also be able to calculate the lengths of those sides, and thus it's all done in one formula. So, using the distance formula, if we want to find the distance from these 2 points, so I'm going to write down my distance formula. And it does not matter which coordinate is coordinate 2, which coordinate is coordinate 1, as long as you are consistent on both. So I'm going to make x2 be negative 5 minus 2 squared plus negative 1 minus a negative 4. Make sure you realize that they are minus signs in the formula. And I would simplify it to negative 7 squared plus, looks like we're going to have 3 squared, which is going to be 49 plus 9. Okay, remembering that anything squared does become positive, and then so we're going to have the square root of 58. And you do need to see if that simplifies. I want you to leave it as a radical, except if it simplifies, so you're going to need to see, does 4 go into it, does 9 go into it, does 16 go into it? I don't believe any of those numbers go into it, so we're good. Just leaving it the square root of 58. Alright, so classifying this triangle as scalene, isosceles, or equilateral. So remembering what you know about scalene is every side is different, isosceles is any 2 sides are the same, or equilateral is all 3 sides are the same. And so we would need to start out with ordered pairs. So it looks like D is at 2, negative 1. E is at 4, 2. And F is at 5, 0. And you need to start finding distances. Okay, and you might have to find all three of them before you can say what kind of triangle it is. So let's call the distance from D to E, and I'm going to do 4 minus 2 squared plus 2 minus a negative 1 squared. 2 squared plus 3 squared. So 4 plus 9, 13. Okay. And then the distance from D to F is going to be 5 minus 2 squared plus 0 minus a negative 1 squared, which is 3 squared plus 1 squared, which is 9 plus 1, which is the square root of 10. And our last one would be the distance from E to F, which really looks a whole lot shorter, doesn't it? So if we did 5 minus 4 squared plus 0 minus 2 squared, we get the square root of 1 squared plus negative 2 squared, which is 1 plus 4, which is the square root of 5. Okay, so looking at those three values, none of them are the same, so this triangle is scalene. So next up, we want to talk about the midpoint formula, and I mentioned earlier that it is the average of the ordered pairs. Average of the x's, average of the y's, so that's what we get. First of all, it is a point, so notice it's an ordered pair, and this is the average of the x's. We add the x's together and divide by 2, and this is the average of the y's. Add the y's together and divide by 2. So if we want to find the midpoint of the segment that joins these two endpoints, so it's an ordered pair, so we're going to add the x's, divide by 2, add the y's, divide by 2. So this is going to be 8 over 2 and negative 11 over 2, which we're going to make into 4, and I would just leave it as negative 11 halves. That is our midpoint. Alright, so our next example, write an equation for the perpendicular bisector of the line segment joining C and D. So there's two things we have to note here. First, we're going to look at bisectors. So we're going to have a line that's going through the midpoint, okay, and it has to be perpendicular, meaning it has to have the opposite reciprocal slope of the slope going through these 2 points. So let's start with that. Let's find the slope going through CD, and so remembering slope is y2 minus y1 over x2 minus x1, and we have 3 over 3, which is 1, and so our perpendicular slope, remember upside down t there is symbol for perpendicular, opposite reciprocal of 1 would be negative 1. So I have a slope, then it's going to go through the midpoint. So for me to find the midpoint, okay, we're going to add the x's and divide by 2, and add the y's and divide by 2. And so we get negative 1 half and 5 halves. So if I have a point, here's my point, that's my midpoint, and I have a slope, I can write the equation of a line if I want to use point-slope form. So remember point-slope form. Okay, and so it's going to be y minus 5 halves equals m times x minus a negative 1 half, so I'm going to do plus. Okay, I'm going to distribute, because I really want to change this over into slope-intercept form. So I distribute the negative 1 and add 5 halves. Negative x plus 2, because that would be 4 halves when you add those together. There's my equation that's going to go through the midpoint, which means it's a bisector, and it has the opposite reciprocal slope, so it's perpendicular, so it fits both of those requirements. By the way, if you did not want to use point slope form, remember you could always use slope intercept form and plug in your point as an x and a y, and you have an m, and so then solve for b and plug it back in. One more thing here, we're going to go over the example in class, but just to write down before then is to recall from geometry that the perpendicular bisector of a chord of a circle passes through the center of the circle. So if you have a circle and you have any chord anywhere, okay, remember what a chord is, that a perpendicular bisector, so if I find the middle and I draw a line perpendicular to it, it has to pass through the center. And so in fact what I can do to find the center is if I have multiple chords, maybe I have another chord here, if I draw in a perpendicular bisector there, it also has to pass through the center, which should tell me that is the center. Okay, every chord, or every perpendicular bisector of a chord has to pass through the center of a circle. And we will use that fact to do our word problem. We'll do that in class. Let me know if you have any questions, and if not, have a great day. Thanks.